Welcome to the Course One podcast. In this podcast, we explore the emerging open financial system. We dive into scalability, interoperability, proof-of-stake, blockchains, and many other parts of this coming financial singularity. Tune in every Monday to dive deep into these cutting-edge projects and protocols with Course One team members and guests.
Hi, this is Brendan from Course One, and today I'm here with Andrew Miller and Vishwanath Raman from Oasis Labs. Hi, guys.
Hi there. How's it going?
How are you doing, Brendan?
Very well, thanks. And we also have Meher from Course One as well. Hi, Meher.
Hello.
So, Andrew and Vishwa, do you want to start by introducing yourself and giving us a little bit of background?
Sure. Yeah. So, first off, thanks for having us. We're excited to be here. It's a great opportunity to talk about blockchain and what we're up to at Oasis Labs. So yeah, like you said, my name's Andrew Miller. I run product marketing here at Oasis. And so really like to get out and talk to folks about kind of what they're up to in the space as well.
And I'm Vishwa. So I'm a solutions architect. So I work more cross-functionally across engineering, product, business development, mostly the customer-facing, parts of our technology, demystifying our technology stack, and then trying to see what kind of use cases might be there that for which we have a solution. So those are the sorts of things that I do.
Okay, that's great. So maybe you can kind of give the audience a bit of background about the Oasis project. So our understanding is it spun out of some research at Berkeley. So can you tell us a bit about who was involved and how that came about? Was the goal from the start to focus on privacy, or was there a team looking to build a blockchain, or how did this all come together?
Yeah, so you're exactly right. We're based in the Bay Area. Our roots really start with Dawn Song, who's our founder and CEO. She's faculty at UC Berkeley, and her reputation precedes her in many ways. She's got over 20 years of experience in security and privacy. And she was doing research with some students and postdocs on the intersection between blockchain and secure enclave or confidential compute technology like SGX, or these secure enclaves. And that's kind of really where it got started. They published a paper called Ekadin, which was really, a research academic paper kind of exploring the project as a concept. And then from there, they decided to actually try to take this project to market. They're looking at blockchains that had been successful at launching and kind of decided in 2018 that they wanted to try to build a company around this. And we're still deeply connected to Berkeley. We've since moved out of Berkeley and are working in San Francisco, but our team has, many students that are coming straight from Berkeley. We've got some other PhDs and professors. Dawn's got a kind of a broad range of connections that she's pulled into the project.
Okay, that's great. So I guess we know it's mostly privacy, I guess, is the primary use case or primary function that this chain has been developed for. Can you talk about the pieces that feed into that just at a high level, right? So we know that you have things like secure enclaves that you mentioned. There seems to be parts of this that use multi-party computation, zero knowledge proofs. You've been doing some work around smart contracts. Can you maybe just give us a high level view of how this solution hangs together and what particular problems you're trying to solve with it?
Yeah, I can take this. So if you think about it, Oasis started out as a privacy-first blockchain platform, like what you mentioned. So from the very word get-go, security has been a focus so that we can build that right into the platform from the bottom up. And in fact, security is one of those things that's often conflated with privacy, with confidentiality, integrity, and so on and so forth. So the way we think about security is that we break it up into three axes. We break it up into integrity, confidentiality, and privacy. So integrity is something that is not just unique to Oasis, but other blockchain platforms as well provide integrity. And what we mean by that is, when you run a transaction, there is a piece of code that's actually evaluating a function or running a function for that particular transaction. We want to make sure that what is running is exactly what you expect. And the next thing that we also want is to make sure that what is being persisted on the blockchain is exactly the result of that computation. So this gives you integrity both in compute and in storage. This is common to all blockchain platforms. Now, what Oasis adds on top of that is confidentiality, so that we can have complete end-to-end confidentiality for transactions. And what that really means is that from the transaction payload to the program state, which is the smart contract state, being encrypted both at rest and in motion and during compute. And that is the promise that Oasis offers. The thing that is not available before Oasis is the fact that you can compute on sensitive information in a way such that even the administrators of the machines that are running these secure enclaves should not get access to what is running inside of them. And so that was not something that was available before Oasis. And so that is the way we distinguish our platform from others. So in effect, you have encryption that is used for data at rest, which includes the state of the smart contracts. You use encryption for the payloads that are actually being sent as a part of the transaction. And then during compute, by using secure enclaves, we are able to provide far higher guarantees in confidentiality. And so the data is decrypted only within these black boxes, if you may. The results are computed inside of these black boxes, and the results are encrypted within the black boxes before getting persisted on the blockchain. So that is the way in which we provide end-to-end confidentiality. So these are the two axes that I spoke about. The third axis is privacy. And in our opinion, privacy is more of an application level concept. You might have confidentiality, but that doesn't necessarily guarantee privacy. Think of it this way. If you, for instance, have, let's say, a database of employee salaries in an organization, and the only query that you permit happens to be the sum of all the salaries of the employees. Now, running that query once before a person joins the company and once after the person joins the company is going to reveal sensitive information, which is the salary that person is making. So you might run this confidentially, but it's still going to be leaking sensitive data. So privacy implies confidentiality and not the other way around. So for us, it's been that play. It is, how do you make sure that you not just run your computation inside of confidential devices like hardware devices, hardware components, but you also want to make sure that the results don't leak any information about the data that went into computing those results. So that is where Oasis distinguishes itself from the rest.
Sounds like a particularly hard problem. Can you maybe tell us a little bit about how you do that?
Yeah. So when it comes to confidentiality, I mean, in terms of confidentiality for data in motion, that is a solved problem. I mean, you use TLS, you have ways by which you can ensure that what is being sent over the network is encrypted. Then what is being stored in storage, that is also something that has been solved. You can encrypt data that is being stored. As long as keys are managed securely, you are okay, right? But then the place where we really need to make sure that there is confidentiality is in compute. And for that, there are multiple technologies. I mean, you can use homomorphic encryption, you can use Intel SGX enclaves. And we find that we want to be able to provide near native performance, which is not something that you get with homomorphic technologies, which is why we chose Intel SGX. So Intel SGX gives you a number of very interesting properties. I mean, you have the capability to run code in protected memory. So both the code and the data that it operates on is in protected memory. And the other thing that it also provides for you is this attestation capability. By that, what we mean is the program that you want to run inside of an enclave is used to define an identity or come up with an identity for that enclave. So there is a measurement process that comes up with an identity for an enclave that includes the binary or the program that you want to run inside of that enclave. So using a process of attestation, remote attestation, you can ensure that the enclave is running exactly the binary that you expect before you hand over keys and before you hand over payloads and before you actually give access to the data in its raw form. So that is the way in which we achieve this. So the protocol has support for it. We have a key manager, and we use potentially key sharding. The keys are generated per smart contract by the key manager, and then everything is encrypted with the public key that is generated by the key manager when it is stored on the blockchain. Also, the payload is encrypted with a public key. The key manager hands over the private key to the enclaves after establishing its identity so that the data can be decrypted, used, and the results can be re-encrypted before being stored on the blockchain.
That is an amazing technical explanation.
I'm glad.
And I'm going to try to just maybe restate it or express it in the form of an example. So the example is, let's say, a standard blockchain vote, right? So there's some kind of proposal and there's a bunch of voters. Let's assume that they are the validators, and each validator votes. And we have to, in the end, we have to know what percentage of the stake voted yes and what percentage voted no. Maybe it's a simple blockchain voting cycle. So what is the meaning of confidentiality here? So you're defining confidentiality to mean that, first of all, the payload is encrypted. So what does it mean? That means that when I, as a chorus, I'm putting in my vote, that's the payload. I'm voting yes or no. And this is my public key that's voting yes, and that's the payload. And this has to be encrypted, shielded from the rest of the world.
Exactly.
Then data in motion has to be encrypted. So when let's say I have put in chorus public key, yes, encrypted it, I'm sending this data over to some part of the Oasis network, that when that data is in flight, it has to also be encrypted. Nobody should actually be able to decode that package. Then the third thing that needs to be encrypted is when my data in an encrypted form hits the blockchain. So, and everybody else's data is hitting the blockchain. So this is the data at rest, which is the set of all votes people have cast. So that has to remain in an encrypted fashion. And then once the voting process ends, there has to be some computation that has to go to this data at rest, tally all the votes, and then come up with a number like 66% voted yes, 34% voted no. So whatever this program that is doing the computation, its operation in some senses it has also to be shielded. The only thing it should reveal is 66 and 34, nothing else.
Exactly. And that too only to the designated recipients. Not everybody, you may not want that result to be shared freely with the world.
Yes. So even the result could be to designated recipients. And so if you can assure through all of this supply chain, you can assure confidentiality, then you have confidentiality as defined by Oasis.
Exactly.
And in this, the tricky piece has been the confidentiality of that program that's doing the computation. That is the genuinely novel piece, which is being solved using Intel SGX.
That is correct. I mean, I would say even the key management is one of those things where we use elliptic curve cryptography is, I wouldn't say novel, but at least it's a very fine piece of engineering. So there are a number of components that have to fall into place. The protocol has to be robust before you can actually make sure that you can achieve this end-to-end confidentiality. And one of the things about security protocols is that many a times you might, even through composition, you might break certain properties. So one has to be very careful. So I think the protocol has been defined in a way such that we at least can be sure that unless and until, you have one of the advertised SGX vulnerabilities being exploited, it's very hard for you to lose confidentiality or integrity for that matter.
So probably we'll come back to how the technology works a little later in the podcast. But Brendan, if you have other product questions or questions about network, maybe we can build using our common knowledge of what Oasis offers.
Yeah, I think so. I agree with her. Let's come back to some more deep dive on some of that later on. Yeah, can we talk about then the use cases there? Obviously there's a good example there of voting. It seems obvious from what you said that there's huge applications here in DeFi, right? Like the whole issue with DeFi is it's just too open and public right now, right? So you can see there is a lot of interest in how that can be, how privacy can be guaranteed there. But apart from those, like what other use cases are you targeting? Because when I look through your documentation, I see a lot of things about like machine learning and applications in healthcare and things like that. Is that a big part of your target market for this, or is that something that comes along later?
I think really you can imagine the system being very valuable for really any instance where data is sensitive, but also using that data is maybe critical to operations or would be incredibly valuable to a company. So, you can imagine a healthcare scenario where, say, they have very sensitive patient records. They want to train a model to do some kind of predictive drug discovery or something like that. And with the appropriate user permissions and the right system, they can do that, potentially using Oasis in a way that allows data to remain confidential, in the way that we just discussed, but still return a trained model that can more effectively predict a particular illness or something like that. So I think that's definitely a space that we're very interested in. I think places that we've started developing some partnerships, we're working with some Fortune 500 companies, nothing public yet in the healthcare space, specifically around secure data sharing and usage, kind of similar to what I just discussed. And here, it's very similar. It's, folks want to essentially be able to share data and control the usage, even potentially be able to keep that data confidential in use, if they need to. And that's something that's really not been available to them with other systems. Other spaces we're seeing that this is particularly useful are cases where you have really valuable data to individuals. So, for example, I think genomics is an interesting use case. We have some partners in that space that we're working with as well, where these companies really want to be able to empower their users to own their genome data and participate in research or participate in particular genome analyses to discover traits about their genetic information in a way that retains their privacy. So with the Oasis platform, both with confidential compute provided by secure enclaves, but also with a distributed ledger, you can really provide those guarantees around integrity and confidentiality that someone would need to actually own data. I mean, the concept, we can get pretty philosophic here, but the concept of owning data is pretty challenging because data is such a good, it's so good at transferring information. And so it's very easily copied and moved to a point that it becomes really tricky to say that, I own this thing in the way that maybe I can say I own my car or I own my house or whatever. And so we're trying to provide the guarantees needed for someone to really say, hey, I own my genome data and I'm going to opt in or opt out of, a range of different analyses depending on how I want to. I think it's valuable for the genetic space because the data is so sensitive. It's also, this kind of value prop is a differentiator for a lot of SMPs that we've talked to and are working with who are looking to say, I want to stand out from the pack. I want to offer a service that's maybe well established in, like, imagine social media, for example. I want to offer a social media service, but I want to allow users to own their data and really separate myself from, the status quo and offer a more compelling product with stronger privacy and security guarantees.
Sure. Okay, that makes sense. I think there's a little bit of a leap here that I'm struggling to make, though. When I think of what you said about privacy in the context of smart contracts and blockchains, smart contract transactions tend to be fairly lightweight in terms of their processing load and short duration, right? And state tends to be very expensive. So how do you get from there, where we are, say, with Ethereum today, to a model that would scale to big data, whether it's healthcare or shopping data? Like, what other pieces have you layered into the architecture to make that possible?
That's a great question.
Yeah. So the thing is, what I was saying earlier, that the fact that the platform gives you certain guarantees, it gives you integrity, it gives you confidentiality. So given those two properties, what we've done is we've built an application or a product on top of the platform that satisfies two personas. One is the provider of information, or the owner of information, and the other is the consumer of that data. And then these two, the consumption side of the story, where the compute needs to happen over sensitive information, is something that we provision using off-chain compute. So a part of this product is that you use the blockchain for what it's good at. Like what you said, it's going to be for running small transactions. It's going to be good for persisting things in an immutable ledger, all of that using consensus and so on and so forth. But then when it comes to actually running heavy-duty computation, like what you would need in the case of genomics, it could be polygenic scoring, which is again lightweight, but then machine learning training, for instance, is going to be far heavier than that. So for these, the way in which we have so far partnered with enterprises, for instance, is by provisioning off-chain compute. And this off-chain compute is where they will have their binaries that do, for instance, machine learning training, for instance, or it could even be constrained SQL querying. And what the platform does is mediating access to that off-chain compute. So matching providers, because providers of data or the owners of data have to provide consent. They also have policies that govern how they expect that data to be used, what specific programs can run on that data. And also consumers are the ones that are contributing these analyses programs, either to compensate the providers or it could even be in kind, in the sense that they're giving them some services, like what we see in the case of our genomics integrations. So in all of these cases, the way in which where our product fits in is in enabling this discourse, where you have the provider with some data, the consumer wants to provide some services, and they can instantiate off-chain runtimes, which is where their algorithms are going to run. And the management of the keys, management of checking policies, all of that happens on-chain, but the actual compute happens off-chain. And so using that combination, we're able to take advantage of the strengths of both of these approaches. One is off-chain, the other is on-chain, to provide pretty much for any of the services or any of the partnerships that we've engaged with so far, what they want to run. We haven't seen an impediment with this model. So
the blockchain is for, in some senses, data aggregation and access control.
You can think of it that way. In fact, not even for data. If you think about it, if I'm the owner of data, you don't even want to put that data on the blockchain. So what I want to do as an owner of data is that I want to encrypt it, and I want to keep the key. And Oasis can be the person or the entity that actually manages my key for me. And I only register a reference to my data with Oasis. So when a consumer wants to get access to that data, Oasis is the one that's going to be giving them not just the reference to that data, but also the key, after making sure that the policies are satisfied, all of this happens on chain. It can happen with confidentiality, which, if you use Intel SGX, also comes with high integrity. So we are using the integrity and confidentiality properties of the blockchain to adjudicate whether a particular consumer can get access to a piece of data, and also while giving assurances to the provider that how it's being used is exactly the way they intend it.
Oh, this is really interesting. So the imagination I get here is that I can store my data encrypted like any place I want. So this can be Amazon S3, this can be my mobile phone that's always on, whatever. And that data is there encrypted. The Oasis blockchain will provide is essentially gating for my data. It will provide other confidential computes access to this data when some of the rules that I have laid down for my data are satisfied.
Correct.
And if let's say on the other side, I don't know, Facebook wants some of my data, then they have to then they essentially on some platform they request access to my data and I give them access to the data. That happens on the blockchain. But once that happens on the blockchain, Facebook can have some private cloud on which the computation happens, and that computation will get access to my data because of the transaction that transpired on the blockchain. Okay, so that is how the blockchain is kept really lightweight, because it's like this gating or access control system.
Correct. And we can use the same mechanisms that we use for our existing on-chain compute, meaning you can still do attestation. And if people have, for example, provisioning enclaves, a provider could very well say that their data can only be used inside of secure enclaves. They can say that it can only be used inside of Intel SGX, for example. And it could also be particular clouds. So, but all of these could be part of the policy that is set by the provider. And Oasis then is going to be responsible for making sure that these policies are satisfied and the binaries are what they are expecting to get access to the data.
Very interesting. Brendan, you want to go ahead?
Yeah, I think actually maybe now is a good time to get back, because I know earlier we said, look, we try and avoid going too deep. Maybe now is a good time, because I think we have a good sense of what this is, how it works, how it all hangs together. Maybe now is a good time to kind of start diving in a bit more on secure enclaves. And have you got specific questions around that, Maher?
So I guess like my question is, so essentially like I'm really imagining my mobile phone here, and I'm saying I want the entire data of my mobile phone to be, in some sense managed by Oasis, right? And so I can think of this blockchain network as a glorified key manager of some sort. So all the data in my mobile phone is encrypted. There's some encryption key, and this encryption key is known to the blockchain, and it's going to provide access to this key only when I approve certain things. So in the blockchain, where is my key being stored?
Interesting point. So the way in which we imagine this is as I was mentioning earlier, on top of the blockchain, we have a product that we have built, which matches personas, providers and consumers. And there is the notion of an identity, right? Because a provider has an identity, a consumer has an identity. And so these are captured by an entity known as a data capsule on the platform. And so the data capsule is a smart contract. It has multiple data sets that have been contributed. Like in your particular case, the data coming from your phone can be one or more data sets that are being held in a data capsule that identifies you as the person that owns that data. And then the confidential state of that smart contract is the one that's going to hold your key. So the association is between the data sets and the keys that are used to unlock those data sets. And the data sets are encrypted. The keys are being held in confidential state on the blockchain, using the mechanisms that I spoke about earlier, which is that the moment a data capsule instance is created, contract instance is created, the key manager gets involved, you have private public keys, the state that is stored on the blockchain is encrypted, and so it's confidential. So that is the place where the key is going to be.
So it's as if like the keys on the blockchain stored inside a smart contract, but everything about that smart contract is encrypted. Nobody can actually pierce through the fog and look at my key.
Precisely.
But then physically, does that mean that key, that encrypted key, now resides on essentially the machines of all of the validator nodes of the network, correct?
I mean, wherever you have a copy of the blockchain, the key is going to be inside there somewhere. But one of the other things is, of course, that you as a provider can also say that there is expiry. You can say that my data is available for a month, after which point it's gone. So those are things that we can also enforce. These are required from, even from a compliance perspective, regulatory standpoint, because GDPR, for instance, expects that users can revoke access to their data at any point, and we need to be able to provably do that. So, but you're right that the key is going to be stored there. It's good. There'll be multiple copies wherever the blockchain is being stored. You'll have a copy of it. But then, considering the fact that it's been encrypted, you just cannot have access to it unless and until you happen to be the person who owns the data capsule. So you have access to it. So there is this strong notion of identities and association of identities to smart contracts and smart contract state. So unless and until a transaction comes from an approved authority or an identity that has the ability to either change state or to remove something, it's not going to happen.
So now the imagination becomes my data, my key encrypted on the blockchain, but that data physically residing on, let's say, 100 validator nodes.
The key.
So the key residing on physical 100 validator nodes. So essentially, like, my worry now has shifted to one of these validator nodes somehow going and extracting my key somehow. Is this key ultimately protected by SGX, and can this key be extracted in some way?
So this is okay. So for that, there are multiple levels of indirection. So the way in which the key manager works is that there is a master key that is sealed. It's in sealed storage. And for every smart contract, we actually derive a key. The key pair for a particular smart contract is derived from a master key. And of course, if the key manager is compromised, then you do get access to sensitive information, right? Because that is the point at which you can actually lose control over the data. But then if a validator, for example, is running an SGX node somewhere, the problem with confidentiality is that, unlike in the case of integrity, even a compromise of a single node is going to compromise confidentiality. So there is that risk.
But then essentially, is it not the case that I'm trusting the weakest of these 100 validators not to compromise?
So the thing is, you have to trust the key manager. That is the thing. So the point where failure can happen, which will be catastrophic, is in the key manager. So if the key manager is compromised, then you will know what the master key is, and then you can actually derive the keys for a smart contract, in which case you can actually break into it. But otherwise, there is no way, I can't see a way by which you can do this, because the validators, more often than not, this is another thing that you should realize, is that when it comes to off-chain compute, if you're looking at enterprise use cases, then your threat model is a little different. Your trust model is a little different. So while what is being run on the blockchain, you're right that the keys are never handed. Okay, so in other words, the keys are never really handed to any compute that is happening on the blockchain. It is only happening off-chain. But then the very fact that the key was registered is something that is happening on the blockchain. So which means that you do have a compute committee that is responsible for committing that particular state, blockchain state, which includes your key. And a compromise at that point can mean that your key can get lost.
And are there some kind of Byzantine guarantees that the key manager can only be broken if X or Y percentage of the validators conspire to break it? Or
you can do that. In fact, if you do key sharding, which is something that is on our roadmap, then the key material is actually stored in multiple places. It's not stored in one place. Then that is one way by which you can provide certain guarantees over and above what you can otherwise. But then again, when it comes to integrity and when it comes to multiple nodes that are participating in committing things to the blockchain, you do have, the BFT mechanism comes in and you need to have a certain majority before you can actually commit to the blockchain. But then for confidentiality, if one of the nodes is compromised, then you do lose confidentiality. So in effect, what I'm saying is one could read, but one can't affect the state of the blockchain. So that remains still with high integrity. But when it comes to confidentiality, unless you compromise the key manager, it's much harder. It's difficult to glean sensitive information. And that can again be addressed by key sharding. There are techniques for that. So there's no single point of failure.
Cool. Brendan, do you have any questions?
Yeah, I might be out of my depth here. I prefer you ask this question here. But what about the recent issues that we've heard from Intel, right, around Spectre and Meltdown and these various hardware compromises? I mean, where does that leave the whole Oasis project? Is that a threat to you guys?
So the way in which we've designed our platform is that confidentiality technology can be swapped out. So for instance, if it is Intel SGX, then we can use, if it's available, then we will use it. But then if it happens to be AWS, then at some point we expect that AWS will come up with Nitro enclaves, in which case we can use that for confidentiality. Then, of course, homomorphic encryption is also possible for select applications. So confidentiality technology is something that we can plug in and plug out. And by increasing the heterogeneity in your compute, for instance, if anything has to be on the blockchain, if it's across SGX and Nitro enclaves when they finally happen, then you get better guarantees than you will otherwise. Even a cloud compromise is not going to be something that would leak sensitive information. So we don't look at that as a threat. We think of it more as an orthogonal concern. We need to be aware of what's happening in the quantum world, what's happening in confidential compute world, but then we are not precluding using other technologies. In fact, Keystone is a project that Dawn is working on with folks from MIT and a bunch of industry partners. So Keystone is an open source enclave. So if you think about it, enclave technology is something that has been closed for a number of, decades probably. When bugs are reported, when bugs are fixed by Intel, there's no way of verifying that they didn't open other doors. If you have an open source initiative like Keystone, then it becomes possible for you to crowdsource and use crowd intelligence to find vulnerabilities and then address them faster. So that is also something that we're investing in, and we're hoping that at some point, if Keystone becomes available, we will incorporate those as for a confidential compute. So there is a strategy in place, is what I'm saying.
Sure. So I guess, all of this is essentially a developer platform, right? Can you talk about, what, I know you're building a lot of tools and frameworks to make this easy for developers. Do you want to just talk a little bit about what it would look like? What's the developer experience here to build confidential apps?
Yeah, so we have a couple of different tools right now. Folks can go check out. We have the Oasis dashboard, which is available through our website, which allows you to deploy smart contracts on a DevNet. You can kind of test things out before you would want to go to production when that's available. Folks can write smart contracts in REST, and so we have a few SDKs to support developing smart contracts in REST, and those can all be found on our GitHub page as well. We've really tried to abstract a lot of the nuances of blockchain away from writing smart contracts. We have some demos online where it really just kind of feels like you're writing a REST application, kind of a few different calls you have to make, but for the most part, it should feel like you're not actually really developing something that's blockchain native. And so that's one piece that we've focused on. We also have a concept called the developer gateway, and so this is for dApps that wanted to go to the route where they wanted to pay transaction fees on behalf of their users, if that was something they're interested in doing. The developer gateway would allow them to do that. And so for folks that, or if you could also alternatively allow folks to have their own wallets. So we have a kind of an ecosystem of different tools and SDKs available on our GitHub that folks can use, with really the goal of kind of abstracting away a lot of the complicated nuances of blockchain and just making it feel just kind of like a traditional development environment.
That's great. Now we'd love to cover some more stuff here. We're just running out of time, so maybe we can kind of wrap up with kind of giving us an assessment of where things are now. I know we're, of course, are very much involved in your incentivized testnet right now, but we're getting very close to the network going live. Do you want to talk about what's on the horizon for the next few months and how things are going as you get ready to get this into production?
Yeah, so like you said, we're in the middle of our QuestNet, or as we call it, but the incentivized testnet, which is going really well. Thank you guys for participating, of course. Mainnet's on the horizon. We don't have an official date yet, but we will of course share with folks kind of once we have more detail there. A lot of it's dependent upon how this next phase of the QuestNet goes, and and just kind of and how development of the network kind of wraps up. But we're looking, I think, timeline, general horizon would be second half of this year or towards the middle of this year. So we're really excited. It's an exciting time. We've got heads down at the company, and everyone's working hard to make sure mainnet goes off without a hitch. And we really appreciate all of our testnet participants for joining the community, for helping out. If folks are interested in kind of learning more, we have a community Slack channel that folks can join. And we have robust documentation as well about how to become a node operator or develop smart contracts if you want to do that as well.
Okay, that's great. Yeah, unfortunately, we have to leave it there. We have so many more questions, so maybe we'll have to do another podcast another time. There's a lot we would have liked to dig into around like your approach to scaling and economics and various different things, but maybe another podcast. But in the meantime, thank you very much, Vishwa and Andrew. It's been a great pleasure talking to you.
Great. Yeah, thank you. Happy to answer any questions in the future. We'd love to come back. This has been a pleasure.
Yeah, absolutely. It was a delight. Thank you so much.
Thanks a minute. Bye-bye.
Thank you for listening to the Chorus One podcast. Visit chorus.one for more information about our work. Don't forget to subscribe to the podcast to stay tuned on new episodes airing every Monday.